Hello and welcome everyone. Today, as you understand from the topic, we will be able to understand, or rather, we will start with the basics of differentiation, or what you call as derivatives. Now, before we start, there are a few things that we need to understand. First one being the formulae. So, as far as formulae are concerned, we will I will give you all a list of formulas that are most commonly used, and then as we move forward and we do different types of sums or numericals, we will keep adding a few formulas throughout this particular series. And by the end of this particular chapter or this particular series, I am hopeful that you will be able to solve a majority of the questions through with the help of this particular teaching. Now, the one of the ways that we will be going about this particular series is, although today being the first part of this particular series, we will be going to the formulas, and then tomorrow onwards, every single day, I will be uploading a specific type of sum. I would definitely appreciate if y'all can, or y'all would like me to solve a particular form of differential equation, or other particular form of an equation, differentiated, and we'll see, and I'll be putting up the solutions for those particular sums also. But then just keep in mind, those sums have to be pertaining the topic, or rather the type of differentiation that we have already completed on that particular day. So as of today, we will start off with a few formulas for differentiation. Now, understanding this, the symbol that we use for differentiation is d by dx. Let's start with a particular type of equation wherein what you will usually get is x to the power of n. Now, x to the power of n means it can be x square, it could be x cube, it could be x to the power 5, or it could be an entire equation raised to the power 5. So in this case, what we will do is, the basic formula is what the power comes to the side, that is, it gets multiplied with the variable, and the variable is reduced by 1. So let's say, for example, if you got something like x to the power 5, and if you have to differentiate it, it becomes what? 5 x to the power 4, because 5 minus 1 is 4. The next formula is the differentiation of log x. Direct formula for this is 1 upon x. Next one, let's say you have to take a derivative of root x. Now, when we have to take the derivative of root x, what would be the derivative of root x? According to the formula, it is 1 upon 2 root x. How do we get this? Well, it's quite simple. Root x is as good as x to the power of 1 by 2. So when you take the derivative, 1 by 2 comes here, and then you subtract from 1 by 2, which is equal to 1 by 2 x raised to minus 1 by 2. And this thing can be written as 1 by 2, which can be written as 1 upon 2 square root of x. This is how you get these formulae. So moving further, what would be the derivative of 1 upon root x? Let's use the same principle and then see what do we get as an answer. So the derivative of 1 upon, to find the derivative of 1 upon root x, we'll first of all simplify this by converting the root to 1 by 2, and then when you bring it up using the law of indices, it becomes minus 1 by 2. So now when I have to differentiate this, minus 1 by 2 will come here, and then x to the power of minus 1 by 2 minus 1. You take LCM between 2 and 1. So what you get is minus 1 by 2 into x to the power minus 3 by 2, which will obviously be written as minus 1 by 2 x 3 by 2. Now x to the power of 3 by 2 can be written as 1 upon 2 x root x. So for derivative of 1 upon root x, the answer is minus 1 upon 2 x root x, or minus 1 upon 2 x raised to 3 by 2. Now let us move on to some other basic differentiation formulae. First one being differentiation of sin x, which is cos x, and the differentiation of cos x is minus sin x. Moving further, differentiation of tan x is sec square x, and differentiation of sec x is sec x into tan x. Further, differentiation of cot x is minus cosec square x, and differentiation of cosec x is minus cosec x into cot x. So as of now, we will be using only these formulae and then doing specific type of sums regarding using these formulae. And as we move further, we will go about doing with different formulas. Also, one more thing. Let's say if you've got a particular equation wherein you have to find the derivative of two different variables. Let's say you've got x raised to 7 into sin x, and you've been asked to find the derivative of this particular equation. How do you go about it? So what you need to understand is there are two parts in this particular equation. First one being x raised to 7 and the other being sin x, meaning these are two variables who have been given different functions. So here, and they are being multiplied to each other. So here what we will do is we will consider this first variable as u and the second variable as v, and the derivative or rather the formula that we will use over here is derivative of u into v taken as u derivative of v plus v derivative of u, meaning x raised to 7 stays as it is, derivative of sin x, plus sin x stays as it is, derivative of x raised to 7. We will be solving these kind of sums in the next series, or rather in the next part of this particular series. Now let's say if you got a similar question wherein, or rather let me just give you a gist of this particular sum itself. So derivative of x raised to 7 into sin x will be, x raised to 7 stays as it is, derivative of sin x, plus sin x stays as it is, derivative of x raised to 7. So this is how you solve it. Now let's say if you've got the same variables in a different form. For example, x raised to 7 upon sin x. So here we will use the formula for division between two functions. Again we consider this as u and this as v. Derivative with respect to x will be v du by dx minus u dv by dx upon v squares, which means the second variable, that is the denominator, stays as it is, and we take the derivative of numerator minus the numerator stays as it is, derivative of denominator upon square of the entire denominator. And then we move further about solving this particular sum, which we will do later on. So as of now, I want you to keep these things in mind. That is, this particular formula of u upon v, this particular formula of u into v, then all of these formulae, trigonometric formulas, and the basics of using x raised to n. Thank you.